All right, I'm going to be talking about something slightly different, a lot of vision stuff. So we're going to be talking about voice and human voice and audio. We are a startup. We're called DeepZen. We're a startup. We started about a year ago. I want to give you some background information on what we're doing, who we are, and why we're doing what we're doing. So we are still fairly new. We officially launched at the beginning of the year. We are 10 people now, mostly PhDs in natural language processing and text-to-speech. And yeah, we've been working closely with IBM since the beginning, so we've been lucky to have their support. And here's a quick preview of who we are. So the two co-founders, me and Talon, at the top left. And we have an international advisory board. We have PhDs from all over the globe, actually. It's kind of, we are a team of 10, but we're all remote, almost. We're in like 5 countries. So that works out pretty well. It just gives a lot more different opinions and inputs. Okay, so why we started DeepZen? DeepZen, while we were doing research, middle of like summer last year, we were trying to figure out, come up with something in the AI space that's gonna disrupt the industry. So we looked at the audiobook industry, and audiobook industry, I don't know, how many of you listen to audiobooks or ever listen to one? Okay, so I think it's gonna become more and more popular. Essentially, audiobook industry is an upcoming industry. It's increasing about 30% a year after year. And we looked at how the audiobook industry today works. It basically works with humans. Humans go into studios, do a lot of recording, and essentially the average time to build an audiobook from scratch is about 6 to 8 weeks and starts from its average is $4,000 to $5,000 for a 10-hour audiobook. So it's a complex process. You have to find a narrator, you have to find a studio, there's a lot of editing involved, and then a lot of the times the narrator needs to go back to the studio and redo a lot of the recordings. And you have to find the right voice actor for the right book. So that's not easy because you start sometimes, you don't like it, and you need to change it again. And it's a time-consuming, costly process. So the opportunity was out there. There are 2 million books printed every year. Only 40,000 are turned into audiobooks, mainly because of this time-consuming and expensive process. And when you go through all this process, all you get is one version of the book, one language, one accent, female or male, and if you want anything more than that, you need to go through this whole process. It's basically you double and triple the cost. So there was a big opportunity there, and we thought, why can't we do this? Why can't we do this with artificial intelligence? So just some of the summary. So it's a $6 billion industry, audiobook growing 30%, but still less than 5% of the print market. And 30% growth is a lot. About 75% of Americans in 2017 read or listened to at least one audiobook. So the opportunity was clearly out there. We also identified other industries, which I'm going to talk later. We're talking to video gaming companies as well and advertising companies for any voiceover stuff, but our main focus has always been in the audiobooks. So after we decided we want to go this way, we tried to figure out how do we do this, because the problem is when you look at when you go to AWS and IBM and a lot of TTS companies already do TTS. So TTS has existed for years. Human quality voice, meaning indistinguishable human quality voice, is fairly new. It became possible with deep neural networks in the past 2-3 years. So you can actually go out and find APIs that synthesize human voice that is indistinguishable. But when you do this, it's usually a sentence or two. So for a sentence or two, it sounds great. But when you try to synthesize a whole book, an article, a paragraph, or basically a larger context, whatever system you use today, it becomes monotonous and boring because there is no emotions and expressivity involved in the synthesis process. And that's because without understanding what the text is saying, it's not possible to synthesize with emotions and expressivity. So in order for that to happen, there was a whole big layer that was always lacking in any text-to-speech products out there, and that's natural language processing. So in order to make this happen, we first need to put together a natural language processing project, and first analyze the text, parse the data, understand the text as much as we can. So, I mean, when I say understand the text, I'm not saying that we can understand the whole book. That's not possible yet. It's just it's a big problem to solve. But we've tried to find something in between. So we tried to do it at a paragraph level or even a chapter level, and basically start from there. So you first try to understand it, and then you tag it with emotions. You basically decide. We identified 9 emotions for our start the project. Our goal is to go up to 23 different emotions in the next year. And you basically identify, you go sentence by sentence, paragraph by paragraph, and you tag it with emotions. And this, when you tag with emotions, it's not like you don't tag it with one emotion. It's really a distribution of the 9 emotions. That's, you basically give a very granular score for every sentence or every paragraph, depending on the context. And then you output that, and you have this enriched, labeled and tagged text. Now you can send to text to speech, and that's how it works. Now the second problem that we need to solve was also we need to solve 2 things. One is replicate what's already out there, which is human-like speech, but more importantly, we needed to figure out how to synthesize emotional speech. We need to synthesize a voice that can go up and down, and there's continuity between sentences. It's essentially, it's in, our goal is to make it indistinguishable for an audiobook. So in order for that to happen, and there's a bunch of other steps that we did. I'm going to go into detail a little bit, but so we have the NLP, we tag it, we send it to text-to-speech, and we have a finalized audio. And we always have incremental emotional training. What I mean with that is we keep adding, finding, and creating our own emotional data set in order to train both both our TTS and natural language processing. And essentially this is voice. So if you think about the industries, in these industries that this applies to are like a lot all over the place. We started with audiobooks. We're looking at voiceovers as well, and the voiceovers meaning any company that needs to do any voiceover for like a demo video that you saw on YouTube, like an introduction video that's 2 minutes long, or any advertising. It applies to this because for all of these, it's always a human going to a studio and doing recordings. Same for game voiceovers. Gaming companies have to go through the exact same process. We spoke to a couple large gaming companies, and it was a big, happened to be a big problem for them as well. And voice assistance is obviously, it's a little bit different in the sense that the implementation of the voice assistant requires a little bit more processing power, a little bit, meaning you need to do some real-time voice synthesis. But the applications are basically endless here. So if you go to do a little bit more technical details is, so the natural language processing is what we have today is, I mean, these are the stuff that we tried, and then we ended up finding that where things were lacking. So we started with a text-based natural language processing, which is the simplest one, which is the most obvious one. But again, it works for a sentence or two, but when you actually try to do this for a large context, there are so many vague sentences, and we're doing with English right now, that is impossible to understand by just looking at the text, how the emotional state of it. So we run into these sentences fairly often. So that's why we are improving on our natural language processing. We're turning into a multimodal sentiment analysis where we not only feed text, but we basically try to find recordings, or we create our own again, that is a video that is we basically extract the text from that video, feed it as text. We extract the facial gestures from that video if it's a person that's speaking throughout the video, and then the third thing is with the voice analysis. So when you actually put all these three together, then you're able to do better emotion extraction. We're still working through this. We're not there yet. It's not an easy problem to solve, but there are approaches out there that are fairly recent. So we're pushing through that. But for now, our system is completely text-based. And we've also integrated with other APIs, and for example, we're integrated with Watson's natural language processing, emotion analysis. So we're able to switch between different NLP systems in real time during synthesis to do a comparison. So it helped us make our NLP better, and then basically test it against the systems that are already out there. On the text-to-speech part, so NLP and text-to-speech for us are completely two different systems. We thought of putting them together, but it just didn't make sense. It did not make sense to put it into one big code base. So we added a controller in between, because these guys, these things only speak through the controller. So when NLP does what it's done, it sends it to the controller, and then controller decides to send it to text-to-speech for speech synthesis. So our speech synthesis system, again, that was another large problem, is there are two types of speech synthesis system. Well, one of them is the older ones. These are all still neural networks. We're not doing any concatenation type of old technology, but these are all the latest technologies. One is a linguistic-based system that we developed, and the other one is end-to-end synthesis system. So the difference between them is linguistic-based systems I'm drawing blanks. I'll come back to that. End-to-end system these are the newer systems, such as WaveNet, Takatron, Google's Takatron, where it learns directly from voice, and it learns how to pronounce directly from voice, so it doesn't need to look at anything else. The problem with these systems are they're very good. They're easy to train. The problem with that is when you try to synthesize a book, just learning from voice requires thousands of hours of training data. So the system actually learns to pronounce every word, because you need to teach it. The linguistic-based system is, I remember the word now, there's actually a predefined phonetic library that you can purchase for every language, different accents. So the good thing about these phonetic libraries is when you actually feed a text to synthesize, it actually already knows how to pronounce for different accents. So that makes life a lot easier. So the end-to-end system, like I said, the problem with that, when you try to build a book, it creates a lot of problems. So what we decided to do was we tried to build a hybrid system. So we essentially, I need to give me 1 second. It's supposed to go to do not disturb. Yeah. Yep. Exactly. All right. So yeah, we decided to put it together and go kind of with a hybrid approach where we utilize the newer technologies, direct learning from voice, but to be safe, we use a linguistic-based system to make sure that we can actually pronounce everything's pronounced well. So another thing that we did on top of this, so this is the base voice system. We built our base voice system where you can train with about 20 hours of data, single speaker data, which actually we had an agreement with a voiceover artist. We put her in a studio and then had her read books for 24 hours. So, that's how we had to start. So with that data, we built a base voice, and base voice meaning a voice with her completely her expressivity. So nothing. If she's very expressive in the training data, then the base voice becomes expressive. If she's just not expressive, so it basically mimics what she already speaks. So the reason we did this approach is we cannot record or purchase so many different data sets that have different expressivity levels. It's just not feasible. You cannot keep recording and recording, and then try to imitate the emotional speech. So we had to come up with another approach, and what we did is style imposing. So in this case, we actually have a multi-speaker. Say we created a multi-speaker set that has expressivity from very little expressive to very expressive. I mean, when I say expressive, I don't know if you've listened to like children's audiobooks. They're super expressive. The voice of the voiceover actor changes frequently, goes up and down. There's cry sounds and everything. So, and then you need to find the right balance between this multi-speaker set to essentially extract different emotions and cluster them together, and then come up with like and tag your expressivity styles, emotions such as happy, angry, sad, all of these, and then we are able to extract these and tokenize these, so we can take these tokens and embed it on top of the base voice. So by doing that, a base voice, that the 24-hour voice that we did, who never actually spoke in an emotional state or an expressive state, can actually start speaking in that state directly by emotions extracted from a completely different voice. So that was the approach that we did. That was the only way of doing it. That was the only feasible way of doing it. So that's what we've been working on. So that's why we have a single and multi-speaker model, single for creating a base voice, multi-speaker model for emotion extraction. And okay, so while we're doing this, so one of the things, the reason I'm presenting here is that we've been working with IBM since the beginning. We actually happened to go to the first meetup, your first meetup in January, in London. And we talked to I wasn't there, but my partner spoke to Chris, and we started with Power AI. We actually rented a Power AI box in March of this year. So we have a lot of cloud credits that we're using. We got credits from AWS, Google, almost $500,000 worth of credits. But we actually and we're only paying for this Power AI box that we have every month, because we're happy to do it, mainly because it's significantly different than what's out there, what you can get on AWS. So there are so many advantages of it. If you need to, you can go read articles about it. But these are the three things that have been very helpful to us, and it's going to be helpful to us. One is the NV link. We have to train with a lot of data. I mean, originally our training. So single speaker set used to train about 3 to 4 days. Multi-speaker set would train in almost 7 to 8 days. So by switching to NVLink, we reduced it by 50%. And I've read about different implementations. I think that it can even go faster for different implementations. But at least for our case, it seems to make trainings twice as fast. So that saves a lot of time, especially we're a startup. We're burning a lot of cash, and like 3-4 days for every training is a big amount to save. So that has been helpful to us from day one. Large model support is an actually later thing we found out, thanks to Chris again. I called you about that. So most of our models actually fit in a single GPU, and that's, I think, for production system, that's how it should work anyway. But because we're trying to innovate, because we're trying to do different things, we try adding a lot of parameters to the model. Grow the model. Sometimes past 100 gigabytes. Then in NVIDIA GPU, 16 gigabytes. The new ones are 32 gigs, which is not easy to get access. But essentially, you are limited with. If you want to have a simple solution, you're limited with 16 gigabytes to fit your model. So large model support helped us there, at least to test different things where we can actually load everything in the memory of the box, and then it basically takes chunks of the model and then puts them into GPUs, and then does its training that way. So because of the NVLink and plus large model support, this works seamlessly, and it's really fast. As if it's communicating between the two NVIDIA GPUs. And the third one is the linear scalability. So we're not using it yet. We're still pre-production. We're trying to go production end of this month by creating our first few audiobooks. and then publishing them. So linear scalability is essentially our process is completely GPU dependent. Right now, if you go to AWS Google, you can get 4 GPUs or 8 GPU setups that are very expensive, by the way. And then if you need to scale more than that, you need to get 3, 4, 5, 6 different systems, and it becomes super expensive. So with linear scalability with Power AI, we have one box right now, a server, but we're actually talking to get another one in the next month. So the way they work, I guess you guys can clarify it if I'm wrong, but you can put 2 servers next to each other and connect them via a special link, I guess, and then you can scale it up to 256 GPUs that run as one system. So this is great for a production level scalability. So that's basically our choice when we go production. All right. So, all right, a little bit more. A little more on the business side. So we are not trying to stay as a technology company only. From day one, we actually wanted to have a tech company that feeds our actual business of creating audiobooks. So with the numbers that I've already told you, it's 6 to 8 weeks. We are able to build an audiobook, a 10-hour audiobook, under 2 hours right now. So compared to 6 to 8 weeks, that's a big improvement. We're trying to we're trying to increase the quality. We're still probably a few weeks away from doing it, which is going to slow down the process a little. But with parallel processing and different methodologies, we're able to synthesize a speech about 10 times the speed of real time. So if you don't know what it means, it's if a speech is 10 seconds long, we're able to synthesize that speech in 1 second. So with that, a 10-hour audiobook we can actually synthesize in 1 hour. So by doing that, we have the capability and the capacity to build as many audiobooks as we want, as much as 24 audiobooks in a day, compared to what Audible has today. Is about 450,000 total they built in the past 8-9 years. And then the second one after that is they have about 250,000. So essentially, we're building a capacity to do that. Obviously, it's not going to be that easy because the first ones we're always going to need quality assurance because there are going to be times that some of the pronunciations are not done well. So many things that need to be QA'd at the beginning. So 1 hour synthesis time, but it's probably going to add 7-8 hours of quality assurance time on top of it, at least at the beginning. But our goal is if we can actually perfect this algorithm, the model, we can do it without quality assurance in an hour. So that creates obviously another business model for us. We are actually launching our own audiobook store called audiowhale.com. We're hopefully be launching it by the end of this month. We are already talking to publishers, we're talking to agents, we're talking to narrators. For narrators of voiceover, I want to make this a point. So we're not trying to replace any voiceover artist's voice. That's not what we're doing. We're actually licensing. We're talking to them and licensing their voice, one by one, so that they can actually make money off of with a revenue sharing model. They can actually make money without ever having to record anything. So that's one of the things that we're careful about, because a lot of the times we get feedback from voiceover artists that we're killing their jobs, but that's not what we're trying to do. So I want to emphasize on that. Because they say AI is going to kill everything, so we're trying not to. And so we're working with publishers, literary agents, writers, and what we're going to do is we're going to start with, we don't want to start directly with only synthetic voice content. We actually want to do mix and match. So we are working with a company to license their existing audiobooks. We're going to launch with that, and then gradually start adding our own content. Our focus is going to be slightly different. We don't want to be a direct Audible competitor, but we want to have some human recorded and synthetic, but we actually want to work more with independent authors. So a lot of existing authors that they already have the means to be able to create their own audiobooks. So $4,000 to $5,000 is not cheap, but it's not an enormous amount. So, but a lot of independent authors, and there's so many of them on sites like Wattpad.com that are very popular in the social media, but nobody ever knows of them. So we would like to actually work with them, and then give them the ability to create their audiobooks with fraction of the cost. And we were talking about, but we can actually, in some sense, we actually want to give it away complete for free, and then do a different licensing agreement. So, so we have the technology view, we have the business view, and we would like to, and when the technology is out there, we would like to capitalize on it as fast as we can. So all this that we're doing, essentially what it does is, speed and cost, we can do in hours rather than 6 to 8 weeks, fraction of the cost. And we have, and the other thing is, when I said 1 hour, that's for one voice, one. So if you want to do multiple voices, it's another hour. If you want to do multiple accents, it's another, you can add another hour on top of it. What we can do, we will have the capability of building more interactive audiobooks where actually every character has a different voice. So we would like to give that ability, so as if like you're listening to a theater on the radio. So that's going to open up new doors. And we want to go a little bit further beyond. That is not necessarily within the AI scope, but while you're listening to an audiobook, if it's on your mobile phone, we would like to give you visual feedbacks or written feedbacks on the screen about, I don't know, if the book is about somewhere in Geneva, and you're going to need to visualize it. So we would like to be able to do that in real time while you're actually listening to it. So there's a lot of things that just because we're saving a lot of cost and money, it's going to give us the ability to add a lot more other functionalities that do not exist out there today. One slide is about, so I talked about audiobooks a lot, and quickly other applications are the voiceover apps. We're talking to a lot of marketing companies, and they love the idea to be able to create a voiceover for their 2-minute video in less than 10 minutes by picking the voice they want and modifying during synthesis time. We're talking to gaming companies. We're actually writing plugins for Unity and Unreal Engine. So a game developer can, while developing the game, they can actually put the script in the code, synthesize it, and directly have it embedded in the game itself without having to ever exit their development environment. And there are a lot of applications, as you can imagine. So quick roadmap is, so we finished end-to-end NLP to TTS integration, human-like acoustic quality. I'm going to play you samples in a minute. Emotional and expressive speech. We are able to control it from NLP as well. So our NLP decides you should tells the TTS you should synthesize it this way, but as the owner of the article, if you don't like it that way, we're going to give them the ability to change, make modifications in the emotion index, and then resynthesize until they actually like it. We're launching our marketplace this quarter. And we're working on speech synthesis on mobile devices, which is going to become critical, because this is very computing power intensive, and for an application on mobile devices, we cannot keep synthesizing on the server, especially when you're talking about hundreds of thousands, millions of devices. So we're working on a solution to be able to synthesize directly on the mobile CPU. And then next year we're going to be adding new language supports. Currently we're only English, and again we're going to be focusing more on the real-time speech synthesis for real-time applications. Right now our focus is batch synthesis, because that's what is needed for audiobooks. You don't need real-time synthesis. And the next year what we were working on, so how I mentioned the single speaker model, we're creating a base voice from 24 hours of voice. We're actually trying to reduce it down to 5 minutes, and that's where the voice cloning and adaptation is going to come in handy. So if you can have applications where you can record your voice for 5 minutes on your mobile phone, and you'll be able to duplicate that voice. Right now, the technology is not. We've done it with 20 minutes. You can actually hear the person's voice. That it's definitely her, but the quality of the voice is not that great. So there are different reasons for that. One of them is the size of the multi-speed. You need a lot of data to be able to clone from. So that's going to take some time to put together. And couple sample voices that just going to play a couple sentences we synthesized randomly from books.
The pedagogic traditions in art schools provided an atmosphere of experimentation, personal creativity, and hip culture that were totally lacking in the formal conservatoire atmospheres of the music schools. In all these respects, the art colleges provide an unexpected breeding ground for rock culture. The pedagogic tradition. As a replacement, the band brought in some oddball named Ringo Starr. Ringo was older and had a big funny nose. Ringo agreed to get the same ugly haircut as John, Paul and George and insisted on writing songs about octopuses and submarines.
There's a bunch of other samples, but essentially this is a completely synthetic voice. So hopefully it'll get even better soon enough. And that's it. I did, 41 minutes. Well, actually, no, not like half an hour maybe.